Okay, I'm going to go through Karl Popper here, and I hate to say it, but I think Karl Popper is kind of fun because he's so straightforward, and he is a philosopher in the sense that we would say, for the 20th century, and that he's very rigorous. You'll see him. Bacon is highly readable. This piece by Popper is highly readable, but he has other books on what he calls objectivism. That are extraordinarily sophisticated. And he's an excellent philosopher in a very real sense. But he wrote this as a more popular piece so that people could understand what the nature of science is. And again, it was in 1963. It's still, when people talk about science today, you will hear echoes of this piece, especially if you're going into sciences. Almost anybody who's been trained in the sciences has read this piece and understands it. Okay? And this is on one of the problems he had he's an Austrian. That's Austria near Germany. And he writes about some of the issues he had back in 1919 as a, young academic. And this is a loaded year for a number of reasons. And you may have heard recently about the Spanish flu is ravaging the world. But also a couple of other things. World War I had just gotten over. That was known as the Great War. The world had never seen anything like World War I. And the world was going through a radical transformation in the way it was organized. But also Einstein's theory, which he had really spelled out in 1915 to a degree in 1911, was confirmed. And this was shocking to the intellect of the world. And then he thought about what's the nature of this, and why is this scientific? And the vast majority of people cannot understand Einstein today. So why is this science? And he considered this problem. When should a theory be ranked as scientific? Or is there a criterion for scientific character or status of theory? And that's the nature of this piece. What is science? How is it distinct from other fields of study? I've already pointed out that fields of study such as aesthetics and other things in philosophy work differently. It's not a matter of one is better than the other. It's that science works differently. Okay? And he goes through that, and this has become an accepted norm built on top of what you just saw in Bacon. And he says this in 3. I knew, of course, that the most widely accepted answer to my problem, that science is distinguished from pseudoscience or from metaphysics by its empirical method. And this is a term I've used in class a number of times. In other words, it's the things that can be measured or demonstrated. Measured or demonstrated is what is empirical, which is essentially inductive, proceeding from observation or experiment. I hope you can hear Francis Bacon in those lines, because Karl Popper is screaming Francis Bacon here. That was the common response, and Bacon has absolutely no inherent problem with that response. So what you're not going to see is him dismissing it, but he's going to add a basic distinction to scientific reasoning that you don't see in in Francis Bacon. Especially today, why this is applicable with pseudo-empirical method. There is a lot of really bad science out there, far more than there is of good science. And he's going to get to what distinguishes good science and why the vast majority of people cannot distinguish it. And they pay attention to science news. Among the theories which interested me, Einstein's theory of relativity was no doubt by far the most important. And again, this is 1919. The 3 others were Marx's theory of history, Freud's psychoanalysis, and Alfred Adler's so-called individual psychology. Now, it's very important to know that these were considered to be scientific theories, and I'm going to emphasize they are still very rational and quality understandings of what they're addressed towards. They are too often, by people who don't understand them, dismissed as, worthless. But Popper here is going to make a distinction that I still think is valid. But the distinction that he's going to make first and foremost is the distinction between Einstein's theory, Marx's theory, Freud's theory, and Adler's theory. And I would argue that Marx isn't even in the scientific realm. He's in the economic realm. And the person who makes the distinction is Eddington. If you're in physics, you know Eddington. You can't get away from him. Okay? The Eddington observation is revolutionized the world. And what he talked about was that he really got dissatisfied. He couldn't come up with a critique of Marxism to dismiss it. And again, it's commonly promoted as a critique of history. But it really was, when Marx designed it, was a critique of economics, and became eventually a critique of history. I found that those theories of my friends who were admirers of Marx, Freud, and Adler were impressed by the number of points common to these theories, and especially to their apparent explanatory power. That should set off alarm bells. That is a deductive property. It's explanatory. In other words, the explanation is projected onto the situation. The theory explains the situation even before the situation is understood. And notice this: once your eyes were thus opened, you saw confirmed instances everywhere. Think about the confirmation bias, and you understand what Popper's talking about here. The world was full of verifications of the theory. That, for him, sets off alarm bells. That's the problem. He talks about being dissatisfied. For you, going through people who are making claims for various theories or this, that, and the other thing, if they're going around and finding this situation, that situation to explain it, you've got a problem. Okay? Situation should challenge it, and I'll come back to this. Okay? But the explanatory power is a property of deductive reasoning, not inductive. Popper is working from clarifying a nuance of inductive reasoning that he's picked up from Bacon. The most characteristic element in this situation seemed to be the incessant stream of confirmations, of observations which verified the theories in question. And this point was constantly emphasized by their adherents. This, again, I don't want to shift far away from science, but this is the confirmation bias you see in political discussions with somebody sitting in their chair watching the news. That's another incidence of this. That's what they're doing, is projecting. It doesn't mean that they are wrong. It means that they are engaging in a deductive form of reasoning, and it's a projection. It's a confirmation bias issue. That has nothing to do with what Popper is going to argue is scientific. Okay? So they are essentially sitting in their chairs telling you what really happened in the news as it's going on. Okay? So they're engaging in a verification exercise, not a challenge. Okay? Once in 1919, and this is a nice little story. I love this story. I reported this is to Adler, to him a case which to me did not seem to be particularly Adlerian, but which he found no difficulty in analyzing in terms of the theory of inferior feelings. Although he had not even seen the child, that's the observation that should set off alarm bells. That did not happen. Slightly shocked, I asked him how he could have be so sure, because of my thousand-fold experience. He replied, whereupon I could not help but say, and with this new case, I suppose your experience has become 1,001-fold. In other words, a case that is not experienced for you, you're going to chalk up to experience. He is projecting, and it doesn't mean his theories are somehow unreliable, but what Adler was engaging in with Popper was a case of projection upon a case that he had not even observed. He would not even entertain any challenge to his basic theory. Okay? And Adler is still seen as being a reasonable, psychological theory. I'll get to that towards the end. It began to dawn on me that the apparent strength was the fact of their weakness. That projection, that characteristic of projection, is really the weakness. But that's where they were drawing their strength, was by using that deductive element. And in the end, you can see it echoing back to Bacon. Again, I really want to emphasize, science is ultimately a philosophy that's been worked out by Bacon, Popper, and others. So you can see Bacon playing out in Popper here. And he mentions Einstein in the issue with Eddington's Experiment. What I'll send you to, I won't play it now, in this video. I'll send you to this. This is a video on Eddington. This is a NOVA video, and it's how an eclipse proved Einstein right. And this is again a NOVA video. It's quite good.
In 1915, Einstein published his groundbreaking theory of general relativity. According to his theory, space and time are intertwined. Together, they form a four-dimensional fabric called space-time, and massive objects can warp that fabric. Now, everything in the universe, including light, travels through space-time. So, if the gravity from a massive object warps space-time, the path that light travels in can seemingly bend. This blew people's minds. Up until then, the concept of gravity came from Isaac Newton. In his worldview, space...
Now, what you have here are conflicting theories. Einstein's theory is in conflict with Newton's. They don't melt together. There's no way to say, oh, well, Newton got it really right and Einstein just discovered something new. No, it doesn't work that way. Okay. In fact, boy, I think I would look good with Newton's here. There we go. Boy, this pandemic's been rough. But the important thing to know is that their theories do not work together. Okay. That's important. Their theories are in direct conflict with each other. Newton's idea is that the universe is infinite and goes on forever. Space is infinite, and separated from it is time. And time is infinite and goes back eternally and goes forward eternally. Einstein said no, it isn't working that way. In fact, as you saw at the beginning, space-time is what makes up the universe. And so you get a radically different notion. In Eddington's Experiment, which I won't go into entirely right now, which was conducted during an eclipse in 1919. And he got to check, and this was right after the war. This was part of that revolution in thinking that happened with the end of the Great War. And he says in 13, now the impressive thing about this case is the risk involved in a prediction of this kind. If observation shows that the predicted effect is definitely absent, then the theory is simply refuted. It is, in the language I've used so far this semester, unreliable. It doesn't hold up. The theory is incompatible with certain possible results of observation. In the fact, with the results which everybody before Einstein would have expected. Okay? It's not holding up. So that is what Einstein was running into. That observation by Eddington could blow his approach out of the water. He is suddenly not just partially, no, you're wrong. Actually, no. What happened was Newton was wrong. And that's right. You may have heard about Newton and how brilliant he was, and I do still hold that he was probably the most intelligent person who ever lived. But he was wrong ultimately about the basic nature of the universe in space and time. Einstein was much more closer and reliable. And now we have string theory working with things. What we had were two theories in conflict. And the Eddington test would show one to be reliable and the other to be unreliable. That was the risk involved in Einstein's prediction. And Einstein went looking for that test. He worked on it, he tried to figure it out, and he did not conduct the experiment himself. Eddington did it, who understood Einstein's ideas and could put them to the test. So what he sees in good science are risky predictions, okay? Not somebody searching for confirmations. A theory which is not refutable by any conceivable event is not untrue. If it can be refuted, it is either reliable or unreliable. If it cannot be tested by any conceivable event, it is non-scientific. So notice with this, he's got three basic areas here. If it is a scientific theory, it is either proven to be falsifiable but not falsified, or falsified. That's the scientific realm. You're either unfalsified. Notice I'm not saying you've been proven true. You've been shown to be unfalsified. In other words, you haven't been blown out of the water yet. Or you have been blown out of the water. That is what Popper is arguing here. Okay? A third category exists for those theories which can't be tested. Those are non-scientific. That's what they are. They are a different type of reasoning. That's why Adler, Freud, and others fall into that non-scientific realm. Whether or not the Oedipal complex and other things play out, there's a lot of issues with Freud, but there's a lot of things that do make sense. A lot of things that fall in that non-scientific category. Assessments like Beethoven was a great artist and his aesthetics were, just magnificent. And the Ninth Symphony was sublime. Those are entirely non-scientific claims. Okay, I would say they're true and very insightful, especially if you understand Beethoven. But they're not scientific because they're not. You can't derive a test where they're, this didn't hold up to sublime. They're non-scientific realms, and that's where a lot of thinking, good thinking, goes. Too many people divide the world up into scientific and in everything that's not useful. That's not where everything goes. Things don't go to not true. They often go to non-scientific. Okay? Every genuine test of a theory is an attempt to falsify it. That's how you get the status of not yet falsified. In other words, I tried to falsify it, it didn't work. The better theories have been attempted to be falsified over and over and over again, and no test has yet falsified it. Okay? Can you say Darwin? Testability is falsifiability. Some genuine testable theories, when found to be false, are still upheld by their admirers. So again, these are things, this is where you get, quacks arguing for goofy things like vitamin C can cure the pneumonia and cure cancer and heart disease. Those are falsified. Those have been falsified. The claims, it's very odd. The claims for many types of vitamins have already been falsified and shown to be they've been shown to be unreliable. So those have been falsified enormously. One can sum up all this by saying the criterion of scientific status of a theory is its falsifiability. So a scientific theory, when proposed, can be falsified. And a good scientific theory has been challenged. The research has challenged it and tried to falsify it, and it's still standing. So it has not yet been knocked down. So it's not knocked out. All scientific theories can potentially be knocked out. You never have a level of certainty in scientific reasoning. Okay? So I'll leave it there. In section 2, he talks more about Einstein. And again, if you want to understand scientific thinking, go through section 2 and he'll spell it out to you. And again, he did die a while ago, not too long ago, but he's much more pertinent to the 20th century, and anybody working in the sciences today understands basic Popper, has almost certainly read this piece. Okay? Take care, you guys.